Alright, what's up? I'm going to try to do a quick video walking through basically how to dose fertilizers if you're buying individual salts, if you're buying potassium nitrate, KH2PO4, potassium sulfate, everything like that. So when I got into the hobby, I feel like this was definitely one thing that was not explained very clearly. I was pretty intimidated by it, and it's actually really straightforward. So you have your macros and your micros, right? I'm not going to get into micros here. I use Aqua's micros. They're pre-packaged, they're weighed out and mixed by a professional. You certainly can roll your own micronutrients. It's just not something I really want to set aside time for. You're dealing with much smaller quantities. The accuracy is a lot more important. So this video, I'm just doing a screen recording. We'll walk through how to use the Rotala Butterfly Calculator, how to do different, just the basic math for making sure you're getting the right stuff. And I'll only focus on macronutrients. So that would be nitrates, phosphates, and potassium. So everybody should have some sort of ratio, right? How many parts per million of N to P to K. So for the purpose of this video, we're going to jump over here to the dosing sheet for my 120p. And we're just looking all right here. So this right here is my ratio. NPK. What I will do is you always save K for last, and we'll go over why. So I'll walk you through each of these one at a time. So this ratio, 15 to 6 to 30, means that I'm dosing 15 parts per million into my tank of nitrates, 6 parts per million into my tank of phosphates, 30 parts per million into my tank of potassium. So to get that, you should have some math done for the actual dosable volume of your tank. Long story short, for a 100% water change, I use 65 gallons. And for 75% water change, I use 55 gallons. Pretty rough estimates and round numbers, obviously. Please do that to make life easier on yourself. You don't really need like a measuring with a flow meter as you refill your tank to tick off and count exactly how many gallons and how many tenths of a gallons, or don't drive yourself too crazy with it. This is one of my simpler notes. Trust me, I do drive myself crazy with dosing and fertilizers. Dosing and planted tank is a pretty deep rabbit hole, and you can stay as shallow or as deep as you want with it. So this is just a pretty shallow overview, because like I said, it is straightforward. It's not something to be intimidated by. You get, I don't want to say crazy plant health, because that is more focused around husbandry, optimal CO2 saturation, the other macronutrients, right? The ones we don't normally think about: CO2, light, effective PAR, penetrating down to the substrate level, good flow and circulation, good distribution from that flow of all of our fertilizers, of our CO2, things like that. But even though I doubt you'll get impressively better health from switching over to rolling your own macronutrients, you do save a ton of money, I will say that. And you can control more things. I don't know, let's say something does go goofy in your tank and for some reason you have an absolute ton of nitrates. You can adjust just nitrates if you wanted, without messing with anything else. So we'll keep this ratio in mind, 15, 6, 30, and we'll flip over to the calculator to get into the fun stuff. So you're just going to go to nutrient dosing calculator, right? And I'm going to show you first how to dose dry fertilizer into a tank. So this is a 120p. It's 83 gallons. After water, after everything, it's 75 gallon by interior dimensions. And then I get to the 65 gallons for dosing because I'm subtracting. Obviously the tank isn't full because that would be crazy. We never have water right up to the rim. And I'm subtracting maybe 3.5 inches of the substrate. So we just estimate for 65 gallons. And this is going to generate a couple more prompts as we go through it. So the first thing, alright, my aquarium is 65 gallons. Again, my aquarium's 83 gallons, but this wants to know what we're dosing, so we're just going to tell it we're dosing 65 gallons of water. If you click on pre-mixed here, come up with a pretty cool pop-up list. As you can see, there's a lot of off-the-shelf stuff here. I think this is fairly out of date, but they do have some stuff on here. For some reason, they just have the GH booster from GLA. Yeah, we're not getting it. There's Thrive, Colin Grace's stuff, Tropica, a couple of the bigger ones on there. Flourish, some of the API stuff. However, what we're interested in is do it yourself. So I said I'm going to show you the dry first. So click on dry dosing. And the next prompt it generates asks if we're calculating for estimate of index or something else. And we're going to choose something else. We're going to choose dose to reach a target. I'm not too sure what all this stuff down here does. Probably just guesses by the, the quote-unquote recommended EI ratio of N to P to K, but we're assuming that you have your own that you want to target. If you don't have your own like I do that you want to target, find a cool tank that you like, chat up the cool hobbyist that runs that tank, and talk to them a little bit about, what is your dosing ratio like, and start there, and have fun tweaking it from there, you know what I mean? So we'll do dose to reach a target. Alright. So now we have some extra stuff up here. So we want to dose this water column of 65 gallons to a target of 15 parts per million nitrates. So we're going to say 15 parts per million. Bam. And then obviously it wants to know what we're dosing with. So we'll scroll through and find potassium nitrate. There it is. Calculate. And look at that. It tells you exactly what you have to do. So if I had a jar or a bag of potassium nitrate that I ordered, and it doesn't matter where you order it from, you don't have to order it from, GLA or anything like that. Alpha Chemicals is a good website to get stuff in bulk. I'm pretty sure they have potassium nitrate. You can order these off Amazon. They're simple salt-based chemicals. Brand name does not matter. I really haven't seen any kind of crazy difference in purity or anything like that. So potassium nitrate, this is if we're taking that, weighing it out, and we're just putting it right in our tank after a water change. So I use RODI water completely straight, and I pump it into my tank when I refill. I do large water changes every week. So this is exactly what I do. I have all this math worked out. If you're playing around with this, you'll be back and forth from the calculator a few times, but once you get that ratio or whatever you want to dose dialed in, provided you're doing the same water change, obviously those numbers, the math is never going to change, so you can just put it in a note or a spreadsheet like I do, and there's your quick reference every time you dose the tank. So even though this seems like a long process on the calculator, this only takes me maybe 2 minutes to weigh everything out quick, mix it up in a cup of tank water, dump that cup full of all my macros into the tank. That's it. So 15 parts per million, we calculated. So we need to add 6.02 grams of the potassium nitrate to your aquarium, and it'll tell you what it yields. Don't worry about the fact that there is NO3 and N listed here. We're just paying attention to the NO3 part. That's nitrate nitrogen, and then N is... there's a conversion factor between the two. This would be important if you were dosing with a urea or something like that. I forget what it is off the top of my head, but I have that too written down somewhere. So anyway, it tells us it's going to yield 15 parts per million of nitrates to our tank, which is exactly what we want. That's our target, and it will give you this. So you can have a, a jewelry scale or a more accurate scale. It doesn't really matter. 6.02 grams. You weigh that out. That's it. You dump it in your tank. It will also give you a fairly accurate breakdown of how to do that in decreasing measurements. Half teaspoon, quarter teaspoon, eighth teaspoon. The measurements will get smaller and smaller. It'll tell you how to estimate out that weight of that substance, of that fertilizer, salt, whatever you want to call it. It'll walk you through that if you wanted to do it by volume instead of by weight. I do it by weight because I think it's a little quicker. A lot of, pretty eminent, successful hobbyists do it by volume instead. They measure out with the teaspoons and tablespoons. Both ways work. Doesn't matter what you do. So I want you to pay attention to this down here. It is potassium nitrate, so it does add potassium. This is why I said we'll do our math for potassium dosing last. So we get 9.46 parts per million of potassium just from dosing our nitrates because of the compound we're using. If we jump back here, we see we're targeting 30 parts per million of potassium. And this is why you see this extra yield written down right here. So for potassium nitrate and KH2PO4, I have how much potassium it yields. I already have that calculated out. And if you went through the math for... if you went through the math for that, I added it up. The totals from other sources of K is 12.75 parts per million. So when I go through and I do my dosing for that 30 parts per million of potassium that we're targeting, I subtract this 1275 from it. 30 minus 1275 is 17.25 parts per million. And the 17.25 is what we will actually type in when we calculate for our K dosing. Brief aside there, just to explain how that potassium comes from other sources depending on what you're dosing with. And you can avoid that, but normally you're going to have it tied to something else. I'm scrolling through here. This right here, calcium nitrate. I believe this is what I know Joe Harvey, he switches his dosing up a little. The salts he uses, he switches it up a little from what most hobbyists use. I believe he uses calcium nitrate. I talked to Joe a lot about dosing, and it struck me as different. So obviously, when he's dosing for his nitrates, so he's not using potassium nitrate, he's using calcium nitrate, and bam, yeah, you can assume, so that's not going to affect his potassium. He won't have to do those potassium totals the same way I'm showing in this video, but it will be a little different. He'll have to account for how much extra calcium he's adding into the water if and when he goes to do his dosing for calcium. Now, the difference between me and Joe's dosing is I'm using, in this tank at least, it's straight RODI water. So I am dosing calcium and magnesium on top of my macros. Whereas Joe, I believe part of the reason it's easier for him to use the calcium nitrate, I remember him saying, so I believe his tap water has some measurable amount of magnesium in it. So he's not adding any magnesium to the water, I think. Again, don't quote me on that. This is just an example of, yeah, you can use different salts for different things. Always good to talk to somebody else who uses them that way first, unless this is your thing, you know, if OChem or water chemistry is your thing, you know what I mean? So that's dosing for nitrates. So next we would do phosphates, and we do that with the KH2PO4. Sorry, I can't say that compound name. I'm not going to try to remember it. I've seen this mistake sometimes. I've made it myself. Right down here you have KH2PO4. Right up here you have K2HPO4. They're different things. They have different math associated with them. Significantly different, okay? So most likely you will have KH2PO4. That's what I've seen commonly sold. If you're buying like a name brand like from GLA or something, yes, it will be KH2PO4. So that's what we'll pick in this case. And again, we're not changing this. It's still dosed to reach a target because we are trying to raise our 65-gallon volume of water by 6 parts per million. So we hit our 6 parts per million of phosphates. We'll calculate that out. And there it is. To reach your target of 6 parts per million, you'll need to add 2.12 grams of KH2PO4 to your 65 gallons of water to yield the following. The same thing as in the last example. The difference between P and PO4, the difference between N and NO3. PO4 is phosphate. That's what we pay attention to. There's probably some conversion factor here with the P between the 1.96 and the 6 parts per million. I only know what the conversion factor for nitrogen is because it's involved in dosing urea, so I don't know what the conversion factor for P to PO4 is. Doesn't matter. It's way outside the scope of this video. So that's what we need to add to get our 6 parts per million PO4. And again, you see how much potassium that's adding to the water. 2.47 parts per million potassium. You know what? I think my math is actually different here. This was calculating for 8, maybe? Yeah. So I just never... Look at that. I messed with my phosphate dosing and I never changed it. So I'm targeting 8 parts per million of phosphate. And you see how easy that is to fix. We just plug an 8 into the dose to reach the target box, and there's our new numbers. 2.82 grams to the 65 gallons of water. And again, 3.29 parts per million of K, potassium. There it is. That's how much it yields. That's how much to add to the tank. Again, the reason I wrote them down here is just an easy reference when I'm weighing these out for the water change. And then the last one we would do is K. Remember, we're going to target not 30, even though that is our target, but we're going to target the 17.25 because that's compensating for the potassium coming from potassium nitrate and KH2PO4. Doesn't matter what order you do these in. I could change this to 17.25, then come up here and change this to K2SO4, potassium sulfate. Then calculate it out. There it is. 9.46 grams of potassium. So that's a pretty quick, succinct walkthrough of how to do that. You can leave it there, or you can get fancy with it. So you see I have this broken down into numbers for a 65-gallon 100% water change, or, you know, 75% of 65 gallons is 55 gallons. So I have just quick, here's how much I would have to weigh out for each salt if I was only dosing 55 gallons of water, i.e. if I was only doing a 75% water change. And you could do that for a 50% water. You could do that for whatever you want to. I'll throw in reconstitution here at the end. I really want to keep this video not an hour long. I might do another one on how to do like a macro solution, but this one is just a quick intro to using Rotala Butterfly because I really haven't found like a good write-up for it. That's what I was looking for. I'm like a forum and write-up kind of guy. I digest material way better if I read it, and I didn't find anything like that. But I figured the vast majority of people seem to do well with videos, and I think Rotala Butterfly is maybe better suited to being shown through a screen recording like this, so that's why I chose to do it that way. So might do that video in addition to this one, but for the current video we're on, we're just going to stick to macros, and then we'll cover reconstitution or remineralization, however you want to refer to it. So this is pretty easy. A lot of people recommend, so you should always have more calcium than magnesium. And if you get hung up on ratios, you know, there's I forget the names of all of them, but there's different ratios for different things. Basically, a lot of aquatic hobbyists have ripped this straight from information studies, rules of thumb that is found in like agricultural dosing, terrestrial dosing, right? You should know that doesn't always carry over to aquatics. So I don't know myself how much of those important ratios that we rip off from agricultural people, terrestrial plant people, how much that actually works in our hobby or doesn't work in our hobby, or maybe even doesn't matter in our hobby. But it's basically, you know, there's more literature on it than there is on aquaculture, you know, aquatic plant growth. So it's always a good starting point. And you can definitely, like I said, if you go down the rabbit hole of dosing, you can find hobbyists that really know what they're talking about. You can find chemists that know what they're talking about. You could find people with a lot of agricultural knowledge. You know, Tom Barr and Joe Harvey both come to mind. People like that know basically a lot more about dosing than the rest of us, and you know, pick their brain, start a conversation. There's a lot of interesting information out there. I have everything I know is just compiled from notes and notes and notes on this subject, from reading posts, forum posts, studies done by people like that, anecdotal evidence, repeated and amassed over years. You know what I mean? Tested by other hobbyists, things like that. But a lot of it is still unknown. A lot of it's still an opinion. Like I said, as far as those ratios are concerned, I digress. Most people will recommend anywhere from maybe a 4-to-1 down to 2-to-1 ratio of calcium to magnesium, where calcium is always the larger number, the number that's, you know, more prevalent in the water column. Mine is very low. I'll give that disclaimer. This was in an effort to drop my total dissolved solids down to between 110 and 130 parts per million. I keep a very clean tank. I do very large frequent water changes. I keep up on plant husbandry and trimming almost daily. I do full substrate vacuums with every water change, so dissolved solids and, you know, dissolved organic content in the water column is pretty low to begin with. And then I just needed somewhere to get that extra drop of total dissolved solids, so I dropped my remineralization. And it left me with this, a 2-to-1 ratio of calcium to magnesium. And for that 2-to-1 ratio, because obviously, you know, that's just the ratio, still gives you a pretty big range. At one point I had 30 parts per million calcium to 15 parts per million magnesium. This was dropped down to, as you can see, 12 parts per million calcium, 6 parts per million magnesium. I'm not going to show you these on the calculator, but I'll show you one just to point out when it gives you the yield numbers for calcium sulfate or magnesium sulfate. Let's look at it. I am dosing to reach a target, and my target is 12 parts per million of calcium. See, it's easy. There's a lot of buttons and a lot of options here, but it's really straightforward. The compound name for this might be calcium sulfate dihydride. I'm not sure. But again, you can see half H2O, 2H2O. There's a difference. There's a big difference. Again, KSO4 2H2O, that's going to be your plaster of Paris, your off-the-shelf calcium sulfate, your hoity-toity, overpriced GLA calcium sulfate in a pretty plastic jar, what have you. Make sure you pick this one. It should have 2 H2Os on it. So when you calculate this out, it will give you the yield amount of calcium and it will give you the yield amount of sulfate. But it will also give you the degrees of general hardness, which is pretty cool. Saves you a lot of trouble. So I reconstitute with calcium sulfate and magnesium sulfate. I showed you the calcium sulfate just now. I won't go into the magnesium sulfate on the actual Rotala Butterfly Calculator again. But yeah, it gives you the yield amount of GH that you'll be adding to the water column from dosing your 12 parts per million calcium and your 6 parts per million magnesium. And you can see that that gives me a total GH of 3.07. So I'm basically at 3 degrees of general hardness. And that's it. There's plenty of other stuff you could use to dose calcium and magnesium as well. Calcium chloride is fairly popular, as long as you're not adding a ton of calcium, because there is a toxicity limit for chloride. I've talked with a few people about that at length. You would still need to dose a pretty good amount of it to mess anything up, but just stuff to keep in mind. Do your research do your research in general, even if you're using these that I showed in the video. But if you're jumping outside the box and you're dosing, you know, with some pretty unpopular compound, just look into why it's unpopular. You know, if there's any solubility issues, maybe you can't dissolve that much of it in water, maybe it knocks something else out of solution, you know, it doesn't mix well with another macronutrient, anything like that. Just do your research and read up on it so you don't do something crazy. I think that is all I have for these videos. I will give calcium carbonate right here a brief shout out. So you can see this one will give you results in general hardness and carbonate hardness down here. Calcium carbonate is popular for those who are remineralizing KH. And again, I don't want this to be like a soft water versus carbonate ridden water debate, so I'll drop the video here. I won't go into remineralizing carbonate hardness because I don't do it in any of my setups. They're all 0 degrees KH, complete low to no absence of carbonate in the water column, super soft water. I only remineralize GH. I do not have any measurable carbonates in the water column. So I wouldn't be the best guy to show you how to remineralize KH. And that's all I got for the Rotala Butterfly Calculator. Later.